All right, so here we are with our chained ratio question, and we're going to begin, like we do every word problem, with reading the question sentence first. So, what are we being asked to find? So, it says here, what is the ratio of math students to literature students? Cool, sounds good. So, that's the comparison that we are trying to make. Okay, everybody? The comparison that we're trying to make, one more time, is again the ratio of math students to literature students. That's what we're trying to find. So let me show you what the problem is with this chained ratio question if we were to try to do that straight up. So first what I'll do is I'll just make it very clear. I want the comparison between math and literature. Perfect. So watch what we have here. Let's read this together. In a school competition, the ratio of math students to science students is 6 to 5. Okay, let me read that again. The ratio of math to science, not math to literature, math to science, is 6 to 5. Okay, cool. Let me write that down right over here. Let's just use black and I'll highlight that right there. So I'll just say again, math to science, that's going to be 6 to 5. Perfect. And then in the next sentence, it says, or the other half of the sentence, it says, and the ratio of literature students to science students is 5 to 7. Okay, sounds good. You got to make sure, very, very sure, that you read these properly. So let me highlight this again. Ratio of literature to science, 5 to 7. So I'm going to write here, literature to science is 5 to 7. All right, there we are. There's it all written out. Now, everybody, when you look at all of this, can you remind me, what are the two items, two ideas that we're trying to compare again? Math and literature. That is correct. We want to compare math and literature. How are we supposed to do that, though? Right? How are we supposed to do that? Because if we're trying to do math to literature, this one has math, this one has literature. How do we connect the two? And here's how we're going to do it. Everybody, what is the common factor between math science and literature and science? What's the common idea between them? Not the number. I'm not asking for a number. I'm asking for the common idea. So don't look at those numbers yet. Yeah, they both have science. They both have science. What does that mean? That means if I can get the same number on science, which I don't have at the moment, I don't. Let me show you this. Let me go ahead and take the literature and swap it out with science, so it's on the left side. Let me show you this, everybody. If I were to put these over each other, are the numbers for science the same? Are the numbers for science the same? They are not, everybody. They are not. So can I magically overlap these and then magically say, oh yeah, 6 to 5. Math to literature, 6 to 5. Can we magically say that? No, we can't. Because we're not comparing the same things in the same way. So let me show you how to properly get this done. In the chat box or out loud, or just, thinking to yourself, who here remembers this little idea called least common multiple? Who remembers that idea from way, way, way back in the day? I'm talking back in the days of Vietnam. Yeah, so, least common multiple. Let's go ahead and understand how we can apply that here, everybody. Let me show you how. Everybody, when we have 5 and 7, can y'all tell me what's the smallest number that 5 and 7 can both multiply to? Yeah, that's going to be 35. So let me show you something pretty neat. And again, I'm reminding you, the goal is to get these numbers to be the same. If I can get the number for science to be the same for both, we are good. So let me go ahead and write that right over here. For science, I want 35. All right, let me show the math part, copying that, and I'm going to copy the literature part over here. So let me just put literature. Perfect. So here's all I want to ask myself. Here is all I want to ask myself. For this top one here, what do I multiply 5 to get to 35, everybody? What do I multiply 5 by to get 35? 7. Let's confirm that real quick. 5 times 7, 35. Yes, that is correct. So watch what I'm going to do, everyone. I'm going to take this first ratio. I'm just going to multiply it by 7. That's all I did. That's all I did. The 5 times 7, that's going to give us the 35. Help me out, though, everybody. What is 6 times 7? What's that going to be? 6 times 7 gives us, oh yeah, 42. Okay, cool. Now notice what I just did. And I'm going to do the same thing down here. But listen to me. Everybody, what do I do to 7 to get to 35? What do I multiply this 7 by to get to 35? Yeah, we multiply by 5. Let me go ahead and just wrap this up in parentheses. And I'm going to multiply these by 5. So here we go, everybody. 7 times 5, that's 35. That's good. And now over here, what's 5 times 5? Oh, yeah, that's 25. Cool. There it is. Boom. So, everybody, now that we have the same numbers for science, now can we magically bring these together? Now are we allowed to do that? Yeah, now we're allowed to. This is how a chained ratio problem baits you. It makes you think that everything's already set up for you to go. Here, it's not. You have to make sure that if you're crossing from one ratio to another ratio, that the middleman, this is what I'm going to call it, the middleman needs to be the same. One more time, everybody, write this down. If you're solving a chained ratio question, which is what this is, A to B, B to C. That's what a chained ratio is. And if we expect ourselves to solve them properly, we need to make sure that the middlemen are the same. Once we have that, we can compare. Boom, there's that 35 in the middle. And if we're trying to get our final answer, it is math to literature, which is 42 to 25. Correct answer is answer choice B. And there we go. All right, next problem up, we have this equation where we're solving for x, and we clearly see that it says x over 3 plus 6 equals 17. So here's what we need to take care of. The best way to understand how to undo an equation to solve for the variable, the best way to undo is to understand how we go forward. So what we know is that if I knew what x was, order of operations says divide by 3 first. Once we divide by 3, then we can add the 6. So now we can work backwards. What did I say? The first thing was divide by 3. The last thing was add 6. So we're going to do this. We're going to undo the last step. Undoing the last step is subtracting 6 on both sides. Once we do that, we cancel on the left, and then we get 17 minus 6 on the right, which is going to be 11. So now we have x over 3 equals 11. What we're going to do next, I'll just go ahead and copy this over. And what we're going to do next is the same that we have been doing. It's the opposite operations, working backwards. So to undo dividing by 3, we'll go ahead and multiply by 3, again, on both sides. And once we do that, cancellation happens, giving us x equals 11 times 3, which is 33. And the correct answer here, my party people, is answer choice A.